Finally, I have a microscope! But how do I look into it? And where are the microbes? I need an instruction. Alright, let's Google it. The first and the simplest experiment with a light microscope. Oh, the first link is some niche online. Well, let's see what they're putting in there. They deserve a like and subscription, and I want to repeat it. How to look through a microscope we have figured out a bit. The next question is, what can be observed with it? You can observe something that fits the size. Let's first understand the sizes of objects on Earth. The largest object on Earth is the Earth itself. Its diameter is 12,742 kilometers, or 7,918 miles. Greenland is huge, stretching 1,300 kilometers, or 808 miles from west to east. 10 islands like Cyprus could be placed across Greenland, and 10 Everests could be placed across Cyprus itself. The orbit of the asteroid 1950 DA intersects with the orbits of Earth and Mars. You wouldn't want to meet that. If you stack 10 giant sequoias on top of each other, you get its size. An apple tree is a small tree, but to climb on it you have to try. After all, it is 10 times bigger than a child. A butterfly is 10 times smaller than a child. The mucofungus is 10 times smaller than a butterfly. The size of a poppy seed is easy to remember, exactly 1 millimeter, 0.04 inches. An amoeba is a giant in the microworld, but it is 10 times smaller than a poppy seed, yet 10 times larger than a red blood cell. Bacteria are 10 times smaller than red blood cells, but 10 times larger than viruses. A membrane is smaller than a virus, DNA is smaller than a membrane, and a hydrogen atom is smaller than DNA. The smallest in our list is the proton, the nucleus of a hydrogen atom. Its size is 0.84 femtometers. A hydrogen atom is 100,000 times larger than its nucleus, so there are no suitable examples for the circles between the proton and the hydrogen atom yet. So, the size of suitable objects for the microscope is approximately from 0.2 micrometers to 0.2 millimeters, or from 8 thousandths of an inch to 8 millionths of an inch. We see how the suitable organisms are highlighted in green. What about everything else? Is it not possible? Actually, it is. We can observe smaller objects using other instruments. For example, protons and the particles they are made of can be observed in particle accelerators. Atoms can be viewed in a scanning tunneling microscope, and membranes and viruses can be observed in an electron microscope. And for everything larger, you just need to break it down. Take the Earth, chip off, and examine it to your heart's content. Let's now see how different objects would look if we slightly magnify them, for example by 40 times. Amethyst still looks beautiful and recognizable, but the tiny crystals seem to turn into magical mountains. Small grains of sand start to look like boulders. On an owl's feather, we can clearly see the tiny hairs covering it. On a butterfly's wing, we can now see the scales. It becomes a bit clearer what the dust in the corner is made of. You can even see the cells in an onion. If you look closely, you can notice the keratin scales covering a hair. And the paper turns out to be full of holes. Our next assignment is to find objects around us based on their macrophotos. Well then, let's search. It's hard to see, so let's spray some tiny portable magnifying lenses made of water droplets on the TV. Now the pixels are clearly visible. I don't know about you, but I just love Giant Microbes plush toys. Their creators did a great job. They look like real microbes and they are very cute too. It's great that Giant Microbes allowed us to use images of their toys for our assignment. Let's try to match each toy with the real microbe so we know what to expect under the microscope at high magnification. This is Clostridium botulinum. It can be found in swollen canned goods. It's best if it doesn't end up in your mouth. And what is this micromop? Oh, it's the penicillium fungus, from which Alexander Fleming made the first antibiotic, penicillin. And this is Anabaena. Anabaena is a cyanobacterium that first appeared at the dawn of life more than 3 billion years ago, and it's still thriving. What does it look like under the microscope? It looks like this. Try to find the rest of the microbes yourself. I'll leave you a link to my website with the educational program in the description.
That's all for today. I wonder, did you manage to see a paper with one eye without closing the other? That's a tricky part usually, and you can leave a comment about it if you want to. And about the next time, I want to discuss different magnifying devices from a magnifying glass to a tunneling microscope. So stop by. I will be happy to see you again. Bye bye.